this video, we want to go over the geometric series and some questions about the geometric series. Geometric series, it's a kind of series that we can find the summation of the series with a formula in the case that a specific geometric series converges. And if diverge, then it's not possible to find the summation. So let's look at the general form of geometric series. It is in the form of sigma n from 1 or any natural number to positive infinity a r to power n. If I start from 0, then the first term of the series is a, and then second one is a times r, then a r squared, and so on. If I look at the terms of this series and the sequence a r to power n, the first term is r, then the second term it's multiplication of the first term with r, the third term it's multiplication again of r and second term, and so on. So we have a as the first term, and then r as the ratio between a2 and a1, between a3 and a2, and in general between an and an minus 1. So this ratio comes from the division of an and an minus 1. If a series has these specific properties, then it is a geometric series. There are the case that absolute value of this ratio it's less than 1. It means that r is between -1 and +1. For example, r is 1/2, 3 over 4.6, -1/2, -0.5, -0.25, or +0.25. In this all of these cases are it's between -1 and +1, then the geometric series converge to a over 1 minus r. So the answer to sigma a r to power n, it's a over 1 minus r. But if the absolute value of r it's equals to 1 or it is greater than 1, then the geometric series diverges, and so it's not possible to find the summation because the summation goes to infinity. Now let's look at some examples about the geometric series and how we approach the problem. The first example is sigma 3 to power n divided by 4, and from 1 to positive infinity. If I want to write the terms of this series, the first term is 3 to exponent 1 divided by 4, which is 3 4, and then the second term is 3 squared divided by 4. The third term is power 3 of 3 divided by 4, and so on. As you see, a or the initial term is 3 divided by 4, and r or a ratio is 3 squared divided by 4 divided by 3 over 4. If you simplify, the ratio here is 3. We know that if the ratio is greater than 1, then the series diverges. How about if the ratio instead of positive 3 was negative 3? Again, because the absolute value of ratio is greater than 1, the series diverges. So in the theorem, we say that if absolute value of r is greater than or equals to 1, then the series diverges. The next problem, sigma -1 to power n 3 divided by 5 to power n from 0 to positive infinity. Now let's look at this example. What is the first term of the series? The first term comes from n equals 0, So it's negative 1 to power 0 times 3 over 5 to power 0. The second term is negative 1 to power 1 times 3 over 5 to power 1. The next term is negative 1 to power 2 times 3 over 5 squared, and so on. So if I simplify, the first term actually is negative 1 to power 0 is 1, right? And then 5 to power 0 is 1. So the first term is 3. Then the second term, negative 1 to power 1 is negative 1 over times 3 over 5. So it's negative 3 over 5. And how about the next term? It's negative 1 squared, which is positive 1. You know that negative 1 to power even is positive, negative 1 to power odd, it's negative 1. So the third term is positive 3 over 5 squared, and so on. So based on the terms of the sequence, you know the initial term is 3 and a ratio is negative 1 divided by 5. If you cannot recognize what is the ratio by just looking at the series, I recommend that divide an with an minus 1. So you can divide a2 by a1, negative 3 over 5 divided by positive 3, and then find the ratio, which is negative 1 over 5. Here, the absolute value of ratio is absolute value of negative 1 over 5. As you see, it is less than 1, so the series converge and converge to a over 1 minus r. A here is 3 and r is negative 1 over 5. So 1 minus negative 1 over 5, it's equals to 3 over 1 plus 1 over 5, right? And then you take the common denominator. The common denominator is 5, so denominator is 6 divided by 5. You can write it as 3 times 5 over 6. After the simplification, the answer is 5 half or 2.5. Now you know the summation of this series, it's 2.5 sigma, and from 0 to positive infinity, negative 1 to power n times 3 over 5 to power n has summation as 2.5, and we say converge to 2.5. For the next problem, we have sigma and from 2 to positive infinity, 2 to power n minus 3 to power n divided by 5 to power n. When we have two or more than one term in the numerator and we have addition or subtraction, we can just separate them and write it as sigma n from 2 to positive infinity 2 over 5 to power n instead of 2 to power n divided by 5 to power n, and then subtraction, and from 2 to positive infinity 3 over 5 to power n. Now we have two geometric series. We can find sigma 2 over 5 to power n, this summation, and this summation. If both of them converge, then the overall series converges. If one of them converge, the other one diverge, definitely the overall series diverge. But if both of them diverge, we cannot say about the overall series. We need to check the overall series separately, not based on knowing divergence of both of these two series. So in this case, both of these two geometric series actually converge. We can evaluate this. So let's evaluate the first one, which is sigma from 2 to positive infinity 2 over 5 to power n. If you write the terms of this sequence, you see the first term of the sequence is 2 over 5 square, and then the next one it's 2 over 5 to power 3 and so on. Just pay attention that the first term of the sequence, it's not 2 over 5, it's 2 over 5 to power 2 because n starts from 2. So in this case, a, it's 2 over 5 squared, and r, or ratio, it's 2 divided by 5. As you see, the absolute value of r it's less than 1, and series converges to a divided by 1 minus r. A here is 2 over 5 square, and r is 2 over 5. So if I simplify, in the numerator I have a square of 2 over 5, and in the denominator you have 3 over 5. Now the final answer is the square of 2 over 5 times 5 over 3. If I simplify 1 5 from numerator and 1 5 from denominator, then the final answer is 4, or square of 2 over 5 times 3, which is 15. So the answer for one part of the question, the first part, is 4 over 15. Now let's find the answer for the sigma 3 over 5 to power n. The second part, sigma n from 2 to infinity 3 over 5 to power n. Again, the first term is the square of 3 over 5. The second term is 3 over 5 to power 3, and so on. So initial term is the square of 3 over 5, and the ratio is 3 over 5. Again, the absolute value of ratio is less than 1, so it converges to a over 1 minus r, where a is the initial term and r is the ratio, 1 minus 3 over 5. So denominator is 2 divided by 5. Now, if you simplify, you have square of 3 over 5 times 5 half. Again, if I cancel 1 5 from denominator and 5 from numerator, then the remaining part is 9 in the numerator and 10 in the denominator. So the second sequence converges to 9 over 10. So the second converge to 9 over 10. Now, if I back to the subtraction, the second one converge to 9 over 10. So the overall 3, you can find that converge to the, if you take the common denominator between 15 and 10, so you have 8 minus 27 in the numerator and 30 in the denominators, which is negative 19 divided by 30. So the series, which is the combination of two geometric series, converges to negative 19 divided by 30. Again, I want to emphasize that when we have addition or subtraction of two geometric series or any kind of series, if both converge, then the addition or subtraction also converge. If one of them converge, the other one diverge, the overall diverge. But if both series, we have two series, AN and BN, let's suppose that AN diverge and BN diverge. What we know about AN plus BN or AN minus BN, we don't know anything, because maybe summation, or subtraction of these two series converge although an diverge and bn diverge. Okay, that's all about the geometric series. Um, I will see you in the next video.